All right, I'm Maddie. My board number is 753859. I'm working with Sam. His board number is
753860.
okay. And now I'm gonna point my aux laser at his stuff. Oh wait, so you should.
There we go.
Good.
That's good, yeah. We'll just label it.
Yeah. This is Sam's board 753860.
Yep, so
And then this is my board, 753859. All right, right now he's pointing his music at mine. All right, he's gonna play a 1K hertz into his microphone, and then hopefully I'll be able to hear it. My speaker's right here. Yep. Yeah, that's working.
all right, this is Maddie. Here's his board. Board number is whatever that is right there. He's got his mic and his laser coming into my board. You read it, there's my board number. All right, Maddie. So that's a 1K hertz signal.
All right, so right now I'm gonna do a quick demo of my indicator lights. So this LED is my microphone. My microphone is turned on right now, and if I were to blow into my mic, you can see it turns on. So yeah, I can hear that. Now I'm gonna turn off my microphone, turn on my aux. I think this one is the aux LED. If I go to my computer, I turn on some music. You can see that now it's on. And I'm gonna pause the music, off, on, off, on, off. So yeah, the LED goes with. All right, so I'm gonna go through and explain the microphone side. So as you can see, my board number is 753859. So I followed the basic diagram shown for the microphone. So from 4.5 through 2.2 k ohms resistance to the microphone, the negative terminal of the microphone is grounded. The output of the microphone goes through a capacitor before going here. Then I needed a very large gain because there's hardly any voltage coming out of the microphone. So I used a 100 ohm resistor, which goes then to V in. V plus is grounded, and then it goes from V in to 100K resistor and a potentiometer, which can go up to 10K of resistance. And then that goes to V out. Then to control the volume, rather than having all of my volume controlled by my gains, I needed such a large gain, larger than a trimmer could give. I have V out go to another potentiometer. It's on the top side. The bottom side is grounded so that the middle can be controlled from 0 up to what the amplified microphone is. Then from that middle, I have it go for my indicator light. My indicator light uses a comparator. It gets compared almost to 0 volts, but since the mic always has some noise, I have it compared to a very small voltage. Like I think I used 100 millivolts. So it gets compared to that. And then if, say I'm blowing into the mic or I'm playing music next to the mic, it'll be larger and the LED will go on. So the output of that comparator goes to a resistor, then an LED, then to ground. From the output of the potentiometer earlier, I also have it go into a 1K resistor where it'll get summed with Vox. Now for Vox, I also just follow the diagram that they said to use. So out of that portion, it goes to a capacitor, and then it goes here. I didn't need as large of a gain, so I have it go through a 1K resistor. Once again, it goes into V minus, V plus is grounded, and then V out runs through just a regular potentiometer with no additional resistor because I didn't need that large of a gain. And then it goes, connecting V out to V minus. Then V out also goes to a volume control knob. I could have just used this potentiometer for the gain, which was for the gain to control the volume, but originally I had a resistor there, and so it wouldn't fully control it. So I have this second volume knob here, and that controls that. And then So it then goes through a 1K resistor where it gets summed with V mic, and it also goes to an op amp where it gets compared with 0 volts. So if it's larger, it'll power the LED to indicate that this Vox is playing sound. Now for the solar cell portion, I just followed the diagram that it included. So I have it go from ground through the solar cell, through a capacitor, and through a 100K resistor to ground so that it creates a DC bias. Then I have it amplified. I use a gain of 100 because I have a 1K resistor here. And well, technically it could be up to 110 because I have a 100K resistor in series with the potentiometer. So it could be anywhere from 100 to 110. And then V out then goes to my buffers. I just followed the images for buffers given. I used 7 buffers. And then, yeah, then it goes to my speaker, and my speaker just goes from the output of the buffers back to ground. And then for my indicator portion, I have it go from the same node with the speakers being powered. I have it go, and I have it be V plus for 4 sides of an op amp. And then for V minus, I used a voltage ladder from a potentiometer so that way, let's say if there's a really loud noise and there's supposed to be really loud noise and the speaker is getting a really high voltage, it'll be larger than the highest part on the voltage ladder. But if it's really quiet, it won't be larger. And then at the output of each of these, I have it go through a 560 ohm resistor and then an LED to ground. All right, and now to go over my LT spice, I'll go through it pretty quickly since it's exactly what's in my circuit. So the simulated voltage coming from my microphone I have being at about 5 millivolts AC, and then it goes through my 100 ohm resistor into V minus. V plus is grounded. Rails are negative 4.5, 4.5, and then I originally had to go through a 2 100K ohm resistors, but in my actual circuit I realized I only need a 100K ohm resistor because it was enough to power the laser. And then I have it go through the resistor and through the diode representing the LED to indicate if it's on. Once again, a small tweak I had to make for my actual circuit is I needed to go through a comparator to compare to 0 volts, and so if it's larger than 0 volts, it'll power the LED. And then I have it go into my summing. All right, now I'm gonna quickly go through my V aux side. It should be quick because it's very similar to V mic and as well to what's actually in my circuit. So I have about 0.2 volts AC coming in from the aux jack, and then it goes here. I have a gain of 10, but I use 10,000 ohm resistor and 100,000 ohm resistor. In my actual circuit, I use 1,000 ohm resistor and I use a 10K potentiometer. Still, it would be a gain of 10. The difference is that with the other one, with the actual circuit, it can be controlled by that gain. Here, it's a set gain of 10. And rails 4.5, negative 4.5, and V plus is grounded. Out of there, in my actual circuit, I have another potentiometer to control volume, but I didn't feature it here because I had planned for my potentiometer here to control the volume, and then I ended up adding a second one to control volume on my real circuit. Out of there, it would go through a 20,000 ohm resistor it would go into the summing side, and it would also go through a comparator compared to 0 volts, and the output V plus would be V aux, V minus would be 0 volts, and then V out would be it would go through a resistor and then through a diode, which represents my LED. I didn't put the comparator here because that wasn't my original design, but I ended up using a comparator in my real circuit. Where they get summed together, I have them here running through 20,000 ohms of resistance. So each one runs through 20,000 and they go into V minus. V plus is grounded, and then V minus goes through 20,000 ohm resistor before going to V out, with the rails being 4.5 and negative 4.5 in my comparator. But in my actual circuit, I adjust that to be 1,000, 1,000, and 1,000. All that matters is that they're the same. It just made more sense to do 1,000 for my circuit. And then from there, I have to go through a 100 ohm resistor and then through this diode that represents my laser back to negative 4.5. So that accurately represents what's happening. For my solar cell, it pretty much accurately represents what's happening in my circuit. The only difference is that I had to play with the resistance values once I had my transmitter side actually working. So I have my simulated AC voltage, about 0.04 volts, and then it goes into an op amp where V minus and V plus and V out are connected through a resistor. V plus is grounded, so that way it amplifies it. I did have to change these resistance values once I was doing my demo because I needed to get a clearer sound and I didn't want it to be oversaturated. And then it needs to go through a series of buffers. Well, not a series, a bunch of parallel buffers, because all of the buffers can only generate so much current. And then it goes through my speaker, which I have represented as an 8 ohm resistor. Now for my LED portion, this is exactly what I have. The only difference is that my resistance values here are 560 in my actual circuit, but this is pretty much exactly what I have, where I use this voltage represents my potentiometer, which I would set at 2.4 volts. It was different from I think I set it at like 1.8 volts on my actual circuit. I played around with it to get it to work better. But yeah, the voltage ladder represents V minus at different stages. V plus is all still the same voltage that comes out of the buffers, which is the same voltage that is coming out of the first op amp. And they get compared, and each of their outputs powers a diode representing a laser. I used 1,000 ohm resistors here. In my actual one, I use like 560 ohm resistors. All right, now I'm gonna really quick demo the indicator lights for how loud it is. So this is for the quietest noise, second quietest, third quietest, and the loudest noise. And I am gonna play some music right now into this. I'll point it here, and you can see that the quietest one's on all the way. That one's there, that one's there, and that one's just barely there, because that's how loud it is. I'm now gonna turn the volume down to play with it. See here, I was at 100. Now I'm gonna go down to 38, and you'll see that it'll be a difference. Now the top one is off all the way, and the third one is flickering. I could put it down even more. And now it's so quiet that, oh yeah. Sorry, I had it too quiet. Now it's so quiet that only the first one is on and the second one is flickering, while the other two are off, because I have the volume at like 14. And let me see if I can find an even middle ground to show. If I put the volume at volume 6, you can see here, only this one is flickering, because it's that quiet. So yeah, and yeah, I was using the volume control here on my laptop.